All right, so continuing in our theme of Unit 8 and pollution, especially water and land pollution, we're going to talk about persistent organic pollutants or POPs, which is kind of a funny name for a terrible, terrible thing. By the way, do not follow the advice that this image is showing you. DDT is not good for you. I put this up here ironically because these are the kind of ads that used to run, and as people later learned, oh, DDT is not good for you. So, what are these POPs, these persistent organic pollutants? They are synthetic, so that means they're usually going to be man made, made in a lab. They are usually carbon based, so they are organic compounds. That's where the organic in the name comes from. They are resistant to degradation. That means that it's hard to break them down through chemical reactions in the environment. Organisms can't break them down, and this last one, photolytic processes, also cannot break them down. That literally means broken by light. If you have ever left something in your car for an entire summer, if you're like me and we are very messy, you may notice it gets kind of bleached by light, and that is because the especially the high intensity ultraviolet radiation that is coming in can break down chemicals. However, these persistent organic pollutants cannot be broken down by this UV light, and so they last in the environment. A lot of these were pesticides that were especially produced after World War II. And one of the big problems is that a lot of these persistent organic pollutants can both be carried by water and by the air because they have a gaseous form. So, when these were first kind of identified as a major environmental problem, there were some international agreements that were kind of set in place called the Stockholm Convention, named after Stockholm, Sweden, where the meeting to kind of address this problem was held. And then they kind of addressed what were called the dirty dozen. These dozen or so pesticides and other chemicals that are persistent organic pollutants. Really, the big ones to know about, DDT is a really famous one, and it's probably the one that I'll mention the most. But just note how many of these are pesticides. Some of these are industrial chemicals, so they're used in industrial processes. And then others of these are actually not produced on purpose. They're byproducts that come from either industrial processes or the breakdown of other compounds. Now, if you look at the structure of these, notice a lot of these tend to have chlorines. These chlorines help make these kind of not only persistent compounds, they also make them toxic. Anywhere you see kind of a joint, so where any lines meet, that's actually representing a carbon atom. And so you'll notice these are these complex structures of rings or chains of rings of carbon with a bunch of chlorines attached. And that's one of the kind of chemical characteristics a lot of these have in common. This is not by any means a list of all of the persistent organic pollutants. This is just kind of the original 12 that were earmarked as chemicals to watch out for and try to reduce the production and release of. So, what does it mean that these are persistent? It means that they don't break down easily. So, we're going to talk about a concept called a half life. And we talked about it briefly with nuclear power. It's the amount of time it takes for half of a substance to break down. In the case of radioactive elements, that would be for half of the radioactive atoms to decay into non radioactive elements. In this case, the half life of a pollutant is going to be the amount of time it takes for half of it to break down. And so notice that all of these have half lives in the amount of years. And keep in mind, a half life just means half of it is gone. It doesn't mean all of it's gone. So let's say you apply a certain amount of DDT. Well, about half of it will be gone after 10 to 15 years. And then after another 10 to 15 years, you'll lose a half of the half that's left, so you'll be down to a quarter. After another 10 to 15 years, you'll be down to an eighth of the original amount, then a 16th of the original amount. So that's what I meant when I said in class, decades after the application of these chemicals, you can still have some remaining. It may not be huge amounts, but if you continue to apply this year after year, so for many years, we were applying DDT year after year after year in large amounts that wasn't breaking down quickly. So the rate of application exceeded the rate of breakdown, and these chemicals started to accumulate in the environment, which meant they were sticking around and they were having long term impacts. One of the big problems with these persistent organic pollutants is that they are lipid or fat soluble a lot of times. That means they accumulate or build up in fatty tissues, which means that the body is not getting rid of them. It's not like you eat some of this DDT contaminated material and, oh, well, your body, like your liver, kind of detoxifies it or you poop it out. No, it stays embedded in your fatty tissue. And so this can be a problem if you're losing weight dramatically. What that means is you have some organisms that will build up a layer of blubber, especially during the colder season. That is blubber, fat tissue that can build up some of these persistent organic pollutants. Then, when you have a like a lean winter, or when you have the spring come around and they or break down that fat, then that's going to release larger amounts of these persistent organic pollutants to kind of get into the rest of the animal's tissues very quickly. So notice, for example, these beta HCHs in this kind of purple ish, I don't know, mauve, maroon kind of color. Notice that it's building up in blubber in very high amounts in some cases. In other cases, you have some of these building up in liver tissue, which can be a bad thing because if you have your liver is what detoxifies things, and if it accumulates too much toxic matter too quickly, then you can have liver failure. So this is showing the amounts of some of these chemicals in various tissues in different mammals that were found in the kind of northern parts of Canada, so that you can see this kind of fat accumulation that's happening. Then these things disperse very far from their region of application. So they can travel by air and they can travel by water and they can travel over long distances. So what you're looking at in this diagram is you're looking at dispersal only through the atmosphere. Then you see some of this, I mean, this is all dispersal through air. Because of this, you not only find some of these persistent organic pollutants in areas near where they've been applied, they've been found everywhere from the Arctic to the Antarctic. And let me tell you, no one's applying pesticides in Antarctica because there is no agriculture down there. It's even been found in the deepest spot in the ocean, the Mariana Trench, which is the deepest point of the ocean in the entire planet. So these things are extremely widespread. Um, which can have consequences because these things can have a lot of negative health impacts for animals in general, and humans are included in that. So this can cause endocrine issues. We talked about endocrine disruptors in a previous set of notes. They can cause reproductive issues. They can cause problems with immune systems, and they can also cause developmental issues, especially nervous system development, which if you're talking about humans, that could lead to like developmental disorders. And then they can also cause cancer. And we're going to talk a little bit more about the effect of the persistence of these in the next lesson on biomagnification and bioaccumulation.